Welcome back, guys, to Tronics Energy, and this is episode 3 of making a digital clock. So right here, what I've added is this circuitry, which is right here. Yesterday we added a CD4017 right here, which was grouping those 10 seconds which were counted by the first decade counter in terms of 60 seconds. So this one represents 10 seconds, 10 seconds, 10 seconds, 10 seconds up to the sixth LED, which will represent 60 seconds are over. So once it reaches the 60th second, we have tapped that output into the clock of CD4026, which is the driver of this 7-segment display. So the function of that connection is for this 7-segment display to count minutes. So this one will be counting minutes which are over once this output goes to the 60th second. So we are going to check that and see if it's possible. So we wait until like that. So once it reaches the 60th second, this one is driven to the next bit, which is number 2, meaning that 1 minute is over since we started this video. But the circuit that you're seeing here has some errors, because I tested it yesterday and I found that it had a lag of I think 1 second. The reason for this is because the NF55, as I said when I'm starting this series, NF55 being the generator of seconds, actually is not really precise, and it's not exact, because you can get internal reference voltage being interfered. We have noises from supply. We have various various things. Maybe the CD4017 is lagging at some point. So all those conditions bring about this lagging of 1 second. And for you to change this, I'm going to use a crystal oscillator next week rather than using an NF55 to produce one has. Okay, let's see, goes to number 3 like that. So as I was saying, I'm going to use a crystal oscillator next week for it to bring a more precise value of 1 Hz, because 1 Hz is what we need. So yeah, so the circuit works pretty okay. You can see seconds are being counted, tens of seconds are being grouped, so this means that 10 seconds are over, then goes to the next one, 20 seconds are over since it started. It's fourth minute, and it's going to go on like that until up to changing this value to number 4. So this is basically what I wanted you to see today, how the circuit is operating. For now, to connect this 4026 to the 7-segment display, you can just check the schematic of this driver. It usually gives you everything that you need, how to connect your 7-segment display, and how to connect the other pins, because it has carry out, it has clock inhibit, it has reset. So you should check all those. Clock inhibit and the reset usually go to ground. The carry out usually goes to supply. Yeah, connection like those, you should just check them in the schematic. And also you check when you're buying the 7-segment display driver, you should check which type of which type of display you're buying, because there are two. They are common cathode and common anode. So this one right here is a common cathode. See, that's why I've connected its common pin to ground. It means that the LEDs inside of this 7-segment display share a common cathode, share common ground. For a common anode, they share a common supply, so you just connect these to the positive part. And depending on the driver, depending on the display you're buying, it also means that you're going to check on its driver, because for 4026 cannot drive a common anode. It only drives common cathode, like this one right here. So you should check on those preferences when you're buying, and yeah, all things will be okay. And also you should protect your LEDs using 1K resistors. That's why I'm using 1K resistors around it. So yeah, so that's what I wanted you to say, and thank you very much, guys, for watching. Please subscribe to Tronics Energy, and I hope to see you next time, where you're going to we're going to replace this seconds generator using a crystal oscillator, which is more precise. So yeah, hope to see you next time. Goodbye.